Hi, my name is Tommy. Welcome to the Semaphore channel. Today we're going to do the basics of Docker. We're going to learn how to take a Node application and put it in a Docker container so we can deploy it anywhere. We are also going to run the application with a database container and Docker Compose. The only thing you need to follow this tutorial is Docker and a text editor. Shall we start? Let's dive in. The first step is simply to create an Express application. We are not going to use any view because we are going to create simply an API application exposing an endpoint. Let's go to the source directory and run npm install to install the dependencies. Here's the demo structure. We have node modules, a few routes, and the package log. So let's create our first endpoint. We're going to delete this one. We're going to call a database file that will host our model for the database. This is not yet created, but let's just declare it here. And let's create our routes. The route all will simply call the DB object. The DB object has a person method that will retrieve persons. It will be mapped to a person table, and simply it returns all the persons as a JSON object. Next, we are going to get a special method to get a specific person by ID. Next, we are going to create a put object. This will create the object. As you can see, we're going to have at least these three fields: ID, first name, and last name. And we are going to return the object created as a JSON. And finally, let's create a delete. So we have a CRUD interface. We're going to delete object by ID. Now let's go to the database itself. We're going to call it database.js, and this will call, we're going to use SQLite as our ORM to facilitate when we need to write SQL code. Let's initialize SQLite, and then we're going to create a connection. We can pass the connection parameters by environment variables, but we can also have same defaults. Next, we're going to create the actual person method, and this will basically have two items. One is the first name, which is a string, and a last name, which is also a string. And finally, we're going to expose both SQLite objects because we're going to need that, for example, to create the tables, and the person, which we are going to call in our API. Now let's create a test database test.js, and here we're going to test the interface with the database. We're going to use jest for this. So first we're going to import the database definition we just created and run before test the sync. The sync method forces the tables to be created on the database, so we don't need to actually run the migration or anything, just to run our test. We will automatically create our tables if they don't exist in the test database. Now let's test first creating a person, and we are going to basically set the ID, the first name and the last name. We're going to use that using the db person.create, and then test is the data row is created in the table. Next, we're going to get one person by ID, and here we are going to test if the string matched to the person that created earlier. Finally, we're going to test the delete person object, and where we destroy or we delete the row by ID. And finally, after all the tests have been executed, we're going to close the connection just to release that resource. Now let's go back to our terminal. We're going to install a few things. We need to install Jest for testing, and we are also going to install PG and SQLite. Now the final thing is simply to add a test command. We're going to add a test script here, which will simply run Jest, and this will run automatically all our tests. Now, if we were to run the test, they will fail because there's really no database running, so the SQLite commands cannot connect to anything. So we need basically a Postgres database running. And since we're doing everything with Docker now, we are going to start a test database using Docker. The latest Postgres version is 16.4, so let's run that. We are pulling the Postgres instance Here, as you can see, we are mapping the default port and running on trust mode, which means we don't really need to supply a user, a password, and a username. So let's open a different tab and run npm test. And this time it should work because we actually have a database running on this tab. So everything is working as expected. Now the next step is to take the application and put that into a container. We're going to create an image and then connect both the image with the container for the Postgres and the container for the image on the same network and run them both in separate containers. Let's go one level up and create Dockerfile. We're going to put it outside the source folder because we usually put that this is not part of the application. So this is the most important part of the whole tutorial. The Dockerfile is a recipe to create the image. So we're going to run a number of directives that will tell the Docker how to create the image. We're going to start with the from keyword, which will determine the base image. So here we have basically a node image. This is a Debian distribution with Node installed. We're going to use the latest Node version at the time of recording this video. So this is our base image. Next, we're going to set a working directory. The application will run from inside this directory. Now, basically, you have cded into this app directory, which already exists in the image. So the next step is to copy package.json and package log.json. We are going to use this for the next step, which is to runs a command inside the container, and npm ci is a special version of npm install that basically does a clean install. Even if there is a node modules directory present on the image, it's going to ignore that, it's going to delete that and create a new clean install. So npm ci is a good alternative to ensure all the dependencies are clean and using the versions determined in the package log.json. Next, we are going to copy actually the code, copy files and copy whole directories. We're copying the contents of the source directory into the app directory inside the container. And finally, to make things a little bit more secure, we're going to run the application using the node user. This already comes with the node image. So we're going to change the ownership to the node user and then switch to that user. So we are not longer running the application with the root user inside the container. Then we have exposed. This simply informs Docker that the port 3000 is interesting, and we can set node m to production, which is a recommended way to run a node application, especially node express applications. And the final touch is to put the npm start. This will run the start command and start the application. The next step is to run docker build. One good thing to have is to create a file that called docker ignore. This will basically make the copy command ignore some files and directories. For example, we can put node modules, and this will not copy the node modules into the container. Now let's build the image. So here we have docker build with a -t with past name of the image. In this case, I'm going to call my application address book, and the dot says we're going to find the docker file in the current directory. This will pull the image, the node image, from the Docker Hub repository and run all the commands, which will install the dependency, copy the files, do the renaming, the changing permissions, and finally summing all up into one image. We can actually see the images with Docker images, and here we have the image we just created 12 seconds ago. Now, the cool thing about Docker is that we can run both the database and the application on containers, and we can coordinate that using Docker Compose. So the next step is to create a Docker Compose file. And in the Docker Compose, we're going to put basically two services. The first service is going to be the database. And here you can see we're pulling the same image we used before. We are setting some environment variables. We can set these variables when we run Docker Compose, or we can pass here defaults. We can also have a health check. This will check if the Postgres instance is up, and a volume will allow us put the data into a separate place where it's persisted. So even if the container is down, the data is preserved. And finally, we have two more settings, the ports we're going to map, and we're going to put this in a private network. So only the containers in this network, which we call backend, can see each other. The second service is the application, and we are going to use here with a nested command. We're going to simply tell that we're going to build this container using the Dockerfile. We are going to pass the same environment variables if they are defined. And we can also have a dependency telling that we cannot run this service unless the Postgres service is healthy. Again, mapping ports. This is the port we are running Express on, and the network. We can also tell Docker Compose to restart the application if it's crashed. So this is why we don't really need, in this case, something like PM2. We can have it, but it's not strictly necessary because Docker Compose can act as a supervisor for this process. Finally, we're going to need two more things: networks to define that the backend network is a bridge connector, and the volume, this is the volume that will persist database data. Now, one cool thing about Docker Compose is that we can run commands inside the services, which are containers in this case. For example, if we want to run the testing, we can just tell the address book container to run npm test. So let's test that. If everything's working as expected, the test should pass. First, we're going to stop this test Docker image that we used earlier. We don't need it anymore. And as you can see, there's no Docker containers running right now. So let's go here and then run Docker compose run. We pass the service, which is address book, and the command, which is npm test. This will resolve the dependencies. It will know that it needs Postgres to run, so we'll start Postgres. Once Postgres is started, it will start the container with the application and run the commands. And here, as we can see, we have passed all the tests. So what do we do if we want to actually start the application to put it into production to serve the API to the internet? Where in this case, we have Docker Compose app. We can pass -d to do it on the background. And here now we are going to see both containers running. So let's see if the endpoints are running. This is the true test. Can I access the application from outside, from my machine? Since this is an only exposes an API endpoint, I can simply run a curl and get users all, and this should return all the users in the database, which is empty, of course. So let's create one user. We're going to create it using the put command, and it returns the JSON object. If we go run curl get all users, we should get that user. Now, what happens if we want to stop the database? Normally, with Docker containers, when we stop the container is lost, and all changes inside the container are lost, which is not good if we are going to run a service that we want to persist data. But the cool thing about this setup is that we have declared a volume. So what happens if we run compose up again? It's going to start the database first. Once that's healthy, it's going to start the application container. And if we run curl, we can see that the data is already there, has been persisted, is not lost. Why is this? Because we have declared a volume in the Docker service and the Postgres service, and we have decoupled the application, the database instance, and the data. Now we want to stop the service, we just turn Docker Compose down and everything is stopped. And we can use this system to basically run our application in the internet with a cheap VPS. Or if we want something more complex, we can use a cloud service, or we can even use the image on Kubernetes. We can run the application on Kubernetes and the database, or we can have different combinations, having the database as a separate service and the application in that container. So we can have a lot of flexibility in deploying and running our application. That's all for today. You can use the same steps to containerize any kind of application. The principles are the same. I'm going to leave links in the description for specific tutorials for various languages and frameworks. Thank you for watching the video to the end. I hope you've enjoyed it. If you did, please leave a like and subscribe. And if you want me to cover some topic in the future, tell me in the comments. Thank you for watching and happy building.